Last week, the biggest rocket ever built was sitting on its launch pad, ready to fly. The countdown reached 0. And nothing happened. Several engines had apparently decided that launching into space sounded exhausting. But on July 24th, SpaceX tried again. This time, all 33 engines roared to life, and Starship Flight 13 lifted off from Texas. What followed may have been Starship's most important flight so far, because this giant rocket did not just fly. It released satellites, traveled halfway around Earth, survived the fiery return through the atmosphere, and landed so gently in the Indian Ocean that it remained floating on the water.
So, what exactly happened, and why does it matter? Let's make it simple. Starship is really two enormous vehicles stacked together. At the bottom is super heavy. Think of it as the world's most aggressive elevator. Its job is to use 33 powerful engines to push everything away from Earth. Sitting on top is Starship, the silver spacecraft designed to carry satellites, cargo, and eventually people. Together, they stand around 124 meters tall. That makes Starship taller than the Statue of Liberty, including its pedestal. Imagine launching the Statue of Liberty into space. Now imagine giving it 33 engines. Actually, don't.
New York has enough problems. A few minutes after liftoff, Super Heavy separated from Starship. The booster had completed its main job, while the upper spacecraft continued toward space. SpaceX is eventually planning to catch returning boosters using enormous mechanical arms attached to the launch tower. Yes, catch them. Most people become nervous trying to catch a falling phone. SpaceX wants to catch a skyscraper filled with rocket engines. But Flight 13 was not attempting that. Instead, SpaceX concentrated on testing the upgraded spacecraft and its heat shield. Then came something Starship had never done on a test flight with real spacecraft before.
It opened its payload door and released 20 next-generation Starlink satellites. Starlink satellites provide internet service from space. These newer versions are designed to offer much greater capacity than previous models. Starship is important because it could carry many of these larger satellites at once. Falcon 9, the rocket SpaceX currently uses for most Starlink missions, is powerful. But comparing Falcon 9 with Starship is like comparing a delivery van with an entire moving truck. Both can deliver your boxes. One can deliver your house. Quick interruption. If you enjoy having enormous rockets explained without needing an engineering degree, please like this video, share it with somebody who loves space, and subscribe to the channel. Now, Starship faced the most dangerous part of its journey, coming back down. Entering Earth's atmosphere at enormous speed creates extreme heat. The air in front of the spacecraft becomes compressed and incredibly hot, surrounding Starship with glowing plasma. This is why the spacecraft is covered with thousands of heat-resistant tiles. They work like an oven glove.
Except the oven is the atmosphere, the glove is attached to a spaceship, and forgetting one tile could become a very expensive afternoon. SpaceX deliberately tested different sections of the heat shield during Flight 13. The company wants to understand which designs can survive repeated flights. That word, repeated, is the entire point. Traditional rockets throw away major components after one mission. Starship is supposed to be fully reusable. The dream is to launch it, return it, prepare it again, and fly it repeatedly, more like an aircraft than a traditional rocket.
If SpaceX can make that work, it could dramatically reduce the cost of carrying large amounts of cargo into space. But Starship is not ready to carry people yet. These flights are experiments. Some previous Starships exploded. Others lost control or experienced engine problems. Even Flight 13 followed a last-second aborted launch attempt after several booster engines failed to ignite properly. That may sound like failure, but rocket testing is unusual. Sometimes the vehicle succeeds. Sometimes it becomes a rapidly expanding cloud of engineering information. Either way, SpaceX collects data and changes the next vehicle. During Flight 13, Starship successfully endured its fiery descent and approached the Indian Ocean. It then performed its landing maneuver and made a controlled splashdown. The landing was so gentle that Starship remained floating while SpaceX's employees celebrated. It was never meant to be recovered and flown again from the ocean. The goal was to prove that SpaceX could control it all the way down. And that matters far beyond Starlink. NASA is depending on a modified Starship to help carry astronauts from lunar orbit to the surface of the moon. SpaceX also wants future Starships to transport enormous cargo and eventually humans to Mars.
Those ambitions still require many more tests. SpaceX must demonstrate orbital refueling, reliable reuse, and the ability to land safely again and again. One successful flight does not solve everything, but Flight 13 connected several major pieces during one mission: a successful launch, satellite deployment, atmospheric re-entry, and a controlled landing. Starship began this month as an enormous rocket whose engines refused to leave the ground. It ended the month floating peacefully in the Indian Ocean after traveling halfway around the planet. For a spacecraft designed to change how humanity reaches space, that is an extremely important step.
Even if, for now, the world's biggest rocket finishes its journey looking like the world's most expensive pool toy.